One of the most common applications for Belleville springs is live loading of flange joints. A flange is normally comprised of two mating flanges, a gasket to provide the seal between those mating flanges, and bolts to keep that assembly together. The flanges are used in piping systems or heat exchangers with the intent to prevent fugitive emissions or process leaks. If the joint leaks, this can result in safety issues. Very often, the fluid contained in a piping system can be flammable or harmful to the environment. As the bolts are tightened, the flange face is loaded against the gasket surface. As this force increases, the gasket material will yield into the microscopic crevices of the flange face, resulting in a seal. However, if the stress on the gasket falls below some threshold level, the fluid contained by the flange will leak. But what provides that load on the gasket? The answer is the bolts. In any bolted system, the bolts can be thought of as springs. As a load is applied to these springs, they are stretched or deflected. If the load does not exceed the elastic limits of the bolt material, when the load is released, the length will return to the same point. This means that the bolts are acting elastically, very much like any spring. The only problem is bolts often act like very stiff springs. One way to illustrate this is use a joint diagram. On the left-hand side of this triangle is the bolting system. The vertical line shows the force on the bolt, and the horizontal line shows the deflection or stretch of the bolt. You can see as the bolt load goes up, the stretch also goes up linearly. This means the bolt is acting elastically. The right side of the triangle reflects the deflection of the gasket. In this case, we only showed the elastic portion of the deflection of the gasket. You will soon see that the right side of the diagram does not affect the results. In this example, let's say the bolt stretch is 4 thousandths and the load is 20,000 pounds. Now, let's say there is some sort of relaxation in the system. This might be due to yielding of the gasket over time or due to differential thermal expansion. If the amount of relaxation was 2 thousandths of an inch, then this would result in a 50% loss in preload. The remaining preload would be 10,000 pounds. The loss of preload is simply a ratio of the relaxation to the bolt stretch. Now, let's take a look at the same gasketed joint, only this one is live loaded with Belleville springs. In this case, the load is still 20,000 pounds. However, let's say that two Belleville springs are added, and each has a deflection of 20 thousandths at 20,000 pounds force. This would result in a total deflection of 20 plus 20 thousandths plus the original 4 thousandths of bolt stretch for a total of 44 thousandths of an inch. Now, if 2 thousandths of relaxation occurs, the loss of preload will only be the ratio of 2 thousandths to 44 thousandths. This would result in a loss of preload of less than 5%. The remaining preload would be over 19,000 pounds. Therefore, by using Solon Belleville springs or flange washers, we can maintain much more preload than a non-live loaded bolted joint. In order to show how live loading of a flange works in practice, Solon designed and built a flange fixture. This is a demonstration tool that reveals how an event like yielding or differential thermal expansion affects a typical set of bolts versus one that employ live loading. The fixture consists of a standard flange design with 8 half-inch bolts and a gasket. In the center of the flange, we have incorporated a differential jack screw that bears on a plate between the flange faces to allow us to unload the entire assembly. This jack screw is used to simulate an event like gasket yielding due to differential thermal expansion. 1/2 turn of the screw represents only a few thousandths of system yield. Each bolt is equipped with a strain gauge in order to continually monitor the bolt preload using Solon's data acquisition user interface. The wavering bolt load values are due to signal noise. To illustrate the benefit of Solon Flange Washers, we will first show what happens when the joint is not live loaded. The bolts only have flat washers under the nut and bolt head. To begin the demonstration, the bolts are tightened in a crossing pattern that is commonly used to tighten flange bolts. This tightening is commonly done in stages of 30%, 70%, and 100% of the final torque in order to evenly load the bolts. A final clockwise pattern is conducted. This process is far from perfect. Elastic interactions occur when the bolts are tightened. The flange faces are drawn together, and adjacent bolts are therefore loosened. Watch here as bolt number 2 is tightened. Bolts 1 and 3 loosen. Even after the 4 tightening patterns, you can see that the bolt load is far from even. For the purposes of this demonstration, we will tighten the bolts as needed to have relatively even loading. Now we see that the bolt load is relatively even. This is a strip chart style view of the bolt load. Each green line represents a bolt load. As you can see, all of the loads are relatively similar. Watch what happens as we simulate a yield in the system by unloading the jack screw. You can see that there is a sharp drop in the bolt load as the yielding occurs. Another yielding event will result in a greater reduction in preload. Now we add live loading to the assembly by adding Solon Flange Washers to each bolt. The bolts are tightened using a similar tightening procedure until the bolts are at the target preload. When we simulate a similar yielding event by unloading the jack screw, we see that there is almost no change in preload. Even with additional yield, the load stays constant. Comparing the results side by side shows that retained preload is much greater when the assembly is live loaded with Solon Flange Washers. This is because the elasticity added to the fastening system is far greater than the yield in a typical flange joint. For assistance with selecting the proper Solon Belleville spring or flange washer for your application, please visit www.solonmfg.com or call 800-323-9717.